Hi, everybody. Welcome back. Hey again to folks on Twitch. We will pick up more or less where we left off. Remember, this week and then into next week, we're talking about root finding. I haven't quite figured out where we're going to fit in anonymous functions. It might be at the end of root finding. We might just wait until we're done with the other stuff too, just so it doesn't get confusing to do a whole different syntax for the thing that we're doing now. But remember, there's no class on Monday. Homework 4 has been posted. There's a comment on there that you can do everything in there except, I think, problem 4. It needs a little bit that we probably won't have time to get to today, but everything else you can do. So I would suggest getting started on that. It'll probably be a little shorter than some of the other ones, at least the first few problems. They may not feel like they're as long as some of the other problems, which is fine. But there is that disclaimer at the top. Try not to copy paste code. I won't know it. It's not like you're doing anything wrong. You'll just be better off in the long run if you don't do that. So let's just briefly review the syntax of F0 since we're going to be using it a bunch today. And then we'll just pick up with that example where we left off last time. So generally what we're looking for is a syntax that looks like something along the lines of solution will be equal to F0. That's the function that we're doing. By the way, the word F0 is because you're trying to find a zero of a function. That F that sits there, we're going to see a few more functions that start with F that are really helpful. And then we generally give this two arguments. The first one is what we call a function handle, which I'm just going to call as RFF of x. So that's the first one. And then the second one, previously we've only used xguess for this one. But I just want to break down two of these a little bit in more detail. This one is called the function handle. The whole thing is called the function handle. The first part, the @x that's sitting here, this is telling MATLAB the variable to solve for. Or I should say, it's telling MATLAB the variable to iterate. So it's all of these root finding functions, whether they're in MATLAB or not, all use an iterative process where they just guess values. They're very intelligent about the way that they guess, but that's all they're doing is guessing values. So when you say @x, you're telling MATLAB, this is the thing that I want you to guess, is the x. It may not be initially clear why do you have to specify that if you also specify it here. That's the part that we probably won't have time to get to today, but we will cover on Wednesday, and the part that's needed for the problem 4. This part is where do I go, right? Which function? So go find a function called RFF, plug into it values of x until the output of that function becomes 0. And that's what it's trying to tell you there. The solution that sits over here, the technical name for that is a root. So sometimes we'll just call that root as the solution. And then the xguess that we have over here, there's two versions of that. The one that we've been using is you can be fairly sloppy with the way that it's used. The other way that you can provide a guess, there's an alternate method. Actually, let's put it up on the top since I know my camera is sitting like right about here. An alternate form is what we call a bracket. So you can tell MATLAB that the root has to be somewhere between a low value and a high value. So you can pass it as a 2-element vector of low comma high or just low space high, and it will force it to search in only that area for the root. And then you don't have to really guess. You can just say it's in between those two regions. And that's the new one that we're going to cover today in just a moment when I switch over here. Just as a review of the steps, let me see if I can zoom in on that one more time. There were about 5 steps, and some of them are a little bit shorter than others. First, you want to write the function and identify the variable. That doesn't have to be a closed form function. So one of the homeworks that you're going to do is that stair-stepping operation for distillation. That doesn't really strike us as what we would think of as a closed form function. You could probably substitute a bunch of stuff, but you can do all that kind of stuff because the result is still continuous. So write function I would kind of think of in quotes. You may not be able to write a single function, you might have to write a few of them, but you should definitely identify the variable. After you've got that, rearrange it to root finding form, which just means put everything on one side. So that step is not, there's very little in the class I would ever say is quote unquote easy. That's probably the only one that I would say is easy because you just move everything to one side. You don't have to do any algebra, any rearrange, well, it is algebra, but you don't have to do any rearranging. Then you plot the function to look for a guess or a bracket. So usually when you do this, that means you're going to have to write a local function. We will typically use local functions, not standalones, just because it kind of carries everything along. It's a nice organizational tool. Then go ahead and use F0 to solve it. And when you're all done, plot to check your answer. And those are the steps that we're going to do. And in fact, those are the steps that I ask you to do on the homework as well. Not so much one, again, because you don't really need to write the function and identify the variable. But you will likely have to do 2 through 5 on pretty much every problem that's on there. Yes. There's 3 different ways that you can write the function. We've done 2, which is a local function and a standalone. The last one is the one I can't decide, do we want to do it next week or at the end of the class, which is anonymous functions. But it does need to be a function. More specifically, you have to give it a function handle. And that's the whole blob that's sitting there. One way or another, you have to give it that. Okay. Let's finish up our example from last time over in MATLAB, and then we'll do one more, and then I will do a third. Well, I won't do a third one. I will give you a third one to do after that. So this is the script where we had started or ended on Wednesday. We had gotten to the point where this script will run and give us the example that or the solution that we want. Let me dock this so the folks on Twitch can see it. So this is where we had stopped last time. We solved the problem. There wasn't anything left to do on this. But I had mentioned that this is only one of the method, right, where we're guessing a single root. You can use just a single value for the guess and say, I think it's close to 1, right, somewhere in that area. The other method is that one that I had just talked about a moment ago. So we're going to comment this out and just compare the other 2 or the other option. So method 2 for F0 is to provide a bracket, which is another way to say that is to bracket the root. So you can imagine something called root bracket, and here we provide a 2-element vector that says, I know it's between here and here. It has to be between here and here. So if I'm looking at a plot like this, I would probably say 0 and 1, just because I know that it's in between 0 and 1. So I would say in between 0 and 1. And then the syntax for F0 looks pretty much the same. The only difference is instead of xguess, you give it a root bracket. Which also, there's no reason at all. I'm actually not in the habit of writing the root bracket separately. I'm more in the habit of writing something like this, where you just provide the bracket directly in the call to F0. But I wanted to pull the root bracket out so that you understand what that number is. It's a way of labeling those 2 numbers that we have on there. But those would give the same answer. And you wouldn't need the intermediate variable if you do it the way that line 29 has it. We should see absolutely no difference whatsoever on our solution, because that's not a very hard root to find. MATLAB ought to be able to find that root pretty easily every single time. The advantage of there's both an advantage and a disadvantage of the bracket. The primary advantage is this is what we use to find multiple roots. So when you've got more than one, what it ends up looking like is just copy pasting this command, which again, I suggest you not do later. And if you call this, for example, root 1 and this one root 2, you can then change the brackets over here. So maybe the second one you've noticed is somewhere between 3 and 3.2, something like that. Each time you re-bracket the root, it will find the root only within that range. So if in your initial plot you notice you have more than one root, using the brackets is how you say, I want to find that particular root. There's not a great way to do that with xguess. You just have to hope that your guess got close enough that it found the root that you're interested in. Whereas the brackets, if there's a root in there, it'll guarantee that it finds just that root that's in between the two. Oops. A disadvantage of the bracket is that the endpoints have to differ in sign. So when I say, for example, RFF of, what did we do up there? 0 is positive, and RFF of, what did we do the other one? 1 is negative. This relies, the bracket notation relies on what's called the intermediate value theorem in math, which is not, you don't have to remember that other than just for a few minutes now. The intermediate value theorem says if your function is continuous and it was positive over here and negative over here, you must have gone through 0 to get there, which I don't know how you get away with calling that a theorem, but it is. The bracket notation requires that to be true. And so you'll just get an error if it's not, which says your endpoints have to differ in sign, and so you just need to narrow your bracket range a little bit, which is something that we will look at now. I didn't mention it on here, but the disadvantage of the single guess, the method 1 that we used up there, is just that you can't really narrow in on a root. So if you've only got one root, use the single guess, that's fine. But if you've got more than one, you're pretty much reliant on the bracketing to find it. Okay, so we didn't have much content there. Let's look at another example. I'm going to use a live script for this so that we can do some math in here, and you can actually see it. So for this one, we'll ask for the roots, find the roots of the expression. Let me zoom in a little bit more so you can see that. If you want to type math in live scripts, you can start with a $sign, and it'll format everything in between there as math, like it'll look like math. And we're going to find 4 is equal to x minus 1 squared. So you don't have to do the left and the right. You can just put the parentheses in there and it'll work. And we're going to look for those roots between -5 and +5. And if you want to be ultra fancy, you put the math in the center like that, like you would see it in a textbook. Save this as example 2. Step 1 was write the function, identify the variable. We've already written the function. The variable is obviously x. There's only one of them. Step 2 was to rearrange to root finding form. There's 2 different ways that we could do that, right? You can always move it to the left or to the right. I'm in the habit of moving everything to the right because it, for me, makes things look a little bit more like they do in a function. So what we end up with is 0 should be really close to this target value that we get, which is just equal to the left side minus the right side. So x minus 1 squared minus 4. Oops, not text, target. If you don't have your math looking like mine, that's okay. You don't need it to look like that. So this is what we're after, right? That is our expression in root finding form, and that's what we then have to find the roots for. And so we're going to do that following steps 3, 4, and 5. 3 was to plot it. So we're going to have to start a local function. So we'll say something like function. I'll say target just because I used target up there, but just so that you don't think it always has to be RFF, we'll call this one my function of x. And the target here will be x minus 1 quantity squared minus 4. Right? Whenever f0 picks a value of x that makes target really close to 0, it'll say, I have found you your root. I have found you your solution. And then we need to plot this over that particular range that we've got. So we'll generate some x's with linspace from minus 5 to 5. We'll evaluate our function. Actually, we'll just say plot x and my function of x as a black line. A lot of this that I'm about to type here is optional. I just like it because it makes things look nice. So a y line through 0 that's red is nice and easy to find. You should, again, get into the habit of labeling your axes. So we'll just put an x and a f of x up here. Or, yeah, f of x is fine. We don't really care what f of x is right now. And then I'm always in the habit of making my axes square, turning the grid on, and drawing a box around everything. Those steps are optional, right? The only thing you really need to get the guess is this part. Everything after that is just the sort of STEM convention for an awful lot of stuff. So here's our plot. So this is an example of what I meant when, it's actually illustrating two things. A, there's two roots, because clearly that black line goes through the dashed red line twice, once a little bit to the left and once a little bit to the right. So we're going to need the bracket notation so that we can say, find the root on the left, find the root on the right. The other thing to note is that the endpoints do not differ in sign. So if I evaluate my root finding function at minus 5, I get a plus 30. And if I do it at plus 5, I get about a plus 11, something like that. So if we give MATLAB a bracket notation that is from minus 5 to plus 5, we'll get an error. So let's do it. Let's make MATLAB suffer. Let's say root 1 is equal to f0 at x of my function of x. Right, that part is standard. And then if we want to capture two roots, we need a bracket. So if we try minus 5 to plus 5, and run that, we get an error, and it says function values at the interval endpoints must differ in sign. That's exactly what I had described a moment ago, right? If you go out to the ends of your range, it's relying on the intermediate value theorem to say one of those has to be positive, one of them has to be negative. It's not that, notice minus 5 is negative and plus 5 is positive. That's not what it's talking about, right? It's evaluating the root finding function at minus 5 and evaluating the root finding function at plus 5, and it's comparing those results. So it's this like plus 30 and plus 10 over here that's causing the problem for f0. So take about, let's go to about 325. Try to find both roots and add their values to the title. So we'll take 5 minutes to try that, or thereabouts. Actually, we'll come back at 3:24. I didn't realize it was quite that time. I will shut up on Twitch, but I am over on Canvas chat if anybody on Twitch has any questions, so I am happy to work with you over there. Oops. Okay, so we've already got a root 1. Let me give us a little bit more. Actually, I'll just zoom out a little bit. Root 1 has been written here. We just need to change the range. So it looks like it's somewhere between 0 and 5. So I'm just going to say 0 to 5. And then root 2, same exact syntax up until you get to the bracket. So now when I want to bracket that root, I need to give it the next bracket. I'm going to say somewhere between like 1 and, I don't know, 5, something like that. The brackets don't need to overlap. It's not necessary that I do, for example, -5 to 0, and then pick up the next bracket exactly at 0. They don't need to overlap, and they also can overlap if they want to. Those are two entirely different commands. F0 does not see one command after the other, so it's really not necessary to change anything in that sense. I'm going to add some dots on here, so we'll put root 1 and root 2 into a little vector and plot them at 0. As, what do we want to do? Marker, face color. How about, we'll stick with red for this one, but we'll change up the colors here in a moment. And then we need to add something to the title. So we'll use sprintf for that. And we'll just say root 1 is equal to something, and root 2 is equal to something else. And we'll pass in root 1 and root 2 as those arguments for sprintf. And then those just go directly into title. You can always nest those too. You can put the sprintf directly inside of title, which actually I think they may have updated title to the point where you can just do that syntax right inside of title, but I can't remember if they did that or not. You may be able to cut the sprint out all together. Oops, forgot to move my hold off. That has to come down here. So it found our two roots. Remember, it's always going to find them as a numerical approximation. If you're particularly good at the quadratic formula, which I'm not, I usually have to look it up, you might be able to eyeball that parabola that we've got there and recognize right away, yeah, those have to be at 1 and 3, or -1 and +3. MATLAB has done its best to find them as 1 and 3, but they are most likely a little bit off. It sort of depends on how accurate you need it to be, but it will often be accurate enough out to at least 6 or 7 decimal points that we just don't care most of the time. It is accurate enough for engineering purposes, and often beyond that as well. So this is an example of finding multiple roots. You'll have a couple of those on your homework as well. We'll just wait maybe another minute or two to for anybody typing along to catch up, and then we'll look at yet another example after that.
Another little question. For the percentage of 3f, what is a floater number and why do you need the percentage sign?
The percentage sign you need because that's how sprintf knows that the thing coming after this is not literally a percentage sign. It's go look at whatever the corresponding input is and put that thing here. Okay. So it's flag inside of the sprintf that says this isn't a normal thing, go look at one of the inputs. The f just means decimal point, like give me a number that's a decimal. If you wanted a number that was an integer, you can say something like %d, and that would write it as just an integer. If you wanted a string, you can say %s, and it will put two strings together. It'll put one string inside of another. Typically, we want something like %.something_f because we are often interested in numbers with a certain number of decimal points after them, which is why we keep seeing %.3f over and over and over and over again.
Okay, cool. Thank you.
The 3, too, just means how many decimal points to show. If you put a number before it, I believe that will, I don't know if it'll pad it with zeros. It doesn't, but if you put a number before it, that'll essentially say how many digits before the decimal point do you want. We don't do that very often because we want all of those.
Awesome. Thank you.
Mhm. Okay, for our last example, and then we'll probably end it here today after this example, we're going to go over to CENG 4. If you took CENG 4, this will look familiar. If you didn't, also okay. This is one of the worksheets that we have to do in CENG 4, and the general setup, for those who took it, I will give you some flashbacks, and those who haven't, don't worry about it. You've got a little reservoir of water down here on the bottom. Water flows through a flexible tube into a pump, and the pump pumps it up, over, and then it'll rise a little bit in one of these stems. It'll go over and rise a little bit in the other stem, and then come out the other side. We can relate the height difference between those two, what are called static pressure taps, to the flow rate through an energy balance. And the energy balance is something that you'll pick up in 101A. That's equation 1 up here. This is the energy balance, and you'll either love it or hate it in 101A, or I don't know, maybe you'll just feel neutral about it. I think it's pretty cool because you can do so much stuff, mostly with these loss terms in here. Those sort of relate theory to the real world. That's where the loss terms come in. But what we ended up doing in CENG 4 was asking you to measure the height difference between the two. So you've got these two static pressure taps, the height will be different in the two of them. If you know those, and then you apply the energy balance, you should be able to figure out what the value of the flow rate is, the Q that sits in here. So pressure drop is proportional to flow rate through this weird complication of equation 3. And what was asked in CENG 4 was to solve that equation, given a delta H and all of these other parameters, solve for Q. That's a pain in the neck because there's a Q squared that sits out here, and there's also an F, and inside of the F, Q is a real pain in the neck. It's in the denominator of a log base 10, and then it's in the denominator of a square root or a square term. I don't think there's a way for you to extract that Q and actually just algebraically solve for Q. I'm going to guess there's no way to do it. I haven't tried to prove it. I don't think I can. But at any rate, this is a great example of something that F0 has no trouble with whatsoever. It can look really complicated on paper, but F0 will find it just fine. So I'm going to copy this over to MATLAB so that we can use it over there. Nice thing about the live scripts, which is what we've been using here previously, is that you can paste stuff like pictures into them. So we'll make that a little bit smaller. So our task will be to solve equation 3 for Q, given the following information. So this is stuff that we would typically determine experimentally in the lab or in CENG 4. So the first thing that we would measure is that delta H, and we're going to say that that's 35, which does actually have units too. It's 35 inches, but we don't really care about the units right now. That sum term, the sum of K sub L, we're just going to set that equal to 0.4. So we're not going to worry about exactly what all of those terms are. We're just going to roll with it and say it's 0.4. And then that script looking L, we're going to set to 60, which is the length of pipe in the region that we need. So we'll move these to the middle. And move back over here. And I'm not going to tell you too much more beyond that. I'm just going to turn you loose until about like 3:40. We'll come back at, actually, we'll say about 3:42. We'll give you about a solid 10 minutes here to work out the answer. This is a fairly difficult calculation in CENG 4 because I don't tell you how to do it in CENG 4. I just expect that you will bang your head against it for a while, especially since in CENG 4 you haven't learned anything in MATLAB at that point. So it's a challenging calculation, and I do it there partly because you're going to come over here and do it in CENG 15. So that is the idea behind this one. So I'm going to turn you loose for about 10 minutes here, and then we'll come back and code up the solution together. All right, if we follow our steps 1 through 5, one's write the equation and identify the unknowns. The equation's kind of written. We're not going to bother to substitute f back inside of there because it's already written pretty cleanly the way that it is. And there's no need for the computation to be all in one line, right? You can subdivide it into lots of smaller lines just to organize your code so that you can read it more effectively. The variable that we need is obviously q, so that's going to be the one that we write our function in terms of. The next thing that we needed to do in step 2, if we go back here, rearrange it to root finding form. That just means moving the delta h over onto the right-hand side. So it'll be blah, 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 all of that times 10 to the minus 4. And then after that, we subtract off the delta h on the other side. Then we need to plot this and look for the roots. So we're going to first have to write the local function, which just, again, so we don't think that variables have to be named a particular thing. I'll call this one output, and we'll call it myRFF of q. And then I'm just going to define those other parameters in here so that it's a little easier for me to write things. So I'll call the one dh for delta h. KL will be our sum of KL terms. And then the scripty looking L will be 60, which we write as scripty L. Then we have to calculate F, which we've got enough of everything to calculate F. It's a little ugly. It's minus 1.8 times log. We have to use log base 10. The default in MATLAB, if you just say log, that's the natural log. So we have to say log 10 in order to ensure that this is log base 10 of 0.05 divided by q. And then we take that entire quantity and raise it to a minus 2 power. This, by the way, when you get to 101A, is called a friction factor. Whereas in like our midterm, we said it was a fudge factor, but you know, it means the same thing. Next, we need our equation in root finding form. So we need something like output is equal to a bunch of stuff, which should be something like 4 times q squared times a quantity of all that junk on the inside. So 4q squared and then 8/3 FL plus KL. So times 8 divided by 3 times F times L plus the KL terms. And then all of that has to be multiplied by 10 to the minus 4 because that's the factor that's coming along at the end. So we'll say times 1e to the minus 4. Only then, don't forget the root finding part. So, don't forget to put it in root finding form. Often I will stop here because I will just forget that it needs to be in root finding form. That has been the source of more than one of my errors. So here we have to also say minus dh, right? Because this puts it into root finding form. Minus dh because we took that from the left-hand side and moved it over to the right-hand side. It could have equivalently been output is equal to dh minus all of that other stuff. That also would have been fine. We got to make a plot to try to find our roots. I have no idea where the roots on this are going to be, so we're just going to pick some values, right? Let's say lin space of, it is a flow rate, so typically those are positive, so we'll at least pick 0, and then we'll just go up to like 2,000. If it's a problem like this where you just have no idea what the order of magnitude could be, you can just start throwing numbers in there and MATLAB will plot it just fine. And then that'll let you sort of zoom in on the root. And then we'll say, what do we want to say? We want to say plot q, and then my RFF of q. Let's make this a magenta line. There we go. And then all that other stuff, hold on. Y line, we'll make it blue. No, green. Hold off. Now our x and y labels actually mean something. X here is q, which happens to be in milliliters per second. If you didn't know it was milliliters per second, that's all right. I took the paragraph away pretty fast, but it is. And our y-axis is the root finding function of q, which, believe it or not, has units of inches on it. Which, on your homework and stuff like that, yeah, if you know the units, try and put them on there, but it's okay if you get the units wrong. As long as it's labeled somehow that the reader would know what is appearing on those axes, that's what you need. And then I like the old axis square and the grid on and the box on. But that's just personal preference. Take a look at what we get. All right, so it's a little hard to read what we've got here. Let me zoom out a little bit so you can see it better. It looks like there is a crossing, but it's way off to the left. So we've gone much too high on the Q side. Even 1,000 is pretty high. So let's cut Q down to about 500 because it looks like the root is back here somewhere in a fairly low portion. So we're going to go from 2,000, which is way too high. 2,000, by the way, would be 2,000 milliliters a second, which is 2 liters per second, which is like filling up one of those big tubs of water. If you say 1,000, you just filled up a whole tub of water. Like, that's a pretty high flow rate for something that we would be doing in a lab. Try 500. 500 is not bad. That's good enough that we can see it. I'm going to change the dashed line on there because I really doubt the folks on Twitch can see it. The dashed line crosses somewhere in between 0 and 200. So that's probably good enough for, it's in fact definitely good enough for bracketing. I'm going to use the bracketing approach here to say where our root is, although a guess of somewhere around like 200 would probably be sufficient. So I will say that my root is F0 at this time Q of my RFF of Q. And I think it's somewhere in between 0 and 200. And then I want to put that in the title. So F's print F will say Q is equal to percentage dot 2 is probably enough milliliters per second. And the value that we put in there is our root. We should also plot it as a dot. So I'll get rid of that hold off. We've got the root here. We'll say plot root at 0 and let's say a magenta circle and marker face color black. We'll invert them. And now say hold off. Notice the bracket that we give here, which I said is 0 to 200, has absolutely nothing to do with the space over which we plot it. The plot doesn't even have to include the root. Remember, the plot is just for you to visualize A, where the root is, and then B, once I find it, did I get it where I wanted it? This bracket doesn't have to correspond directly with any of those. So this could be 10, right? And it's still fine. It's still going to find the root. It doesn't have to be the same range that we had. And actually that's the same as what we saw in the last one where we have multiple roots. We had to subdivide that range, so it's okay if those are different. So this is the pattern that I'm after for homework 4. Remember, try not to just copy paste all of that. I know you can, and I won't know the difference when you turn it in. But that sort of a process going from start to finish, there's a bunch of stuff in there that's really useful. There's linspace, there's plotting, there's the sprintf, there's root finding, there's local functions, there's evaluating stuff. All of that is just kind of bread and butter MATLAB that is really good for you to just practice and get used to because it'll stick with you afterwards. So with that, we'll wrap it up. Have a great long weekend. Remember, no class on Monday, but homework 4 is posted. And it's Friday to Friday one. So it's out today and it'll be due next Friday. I'll wrap it up. See you Twitch. I am over on Canvas chat for a few more minutes too. If you have any questions after the lecture, I'll catch them over there. Otherwise, have a good one and stay safe. We'll see you on Wednesday.